Hi there, welcome to my YouTube channel. My name is Daudi. If this is your first time joining the channel or watching this video, kindly subscribe to the channel. If you find this video interesting or you just like my face, kindly leave a like. So basically today we'll be talking about something called ROI, which stands for region of interest. Now that can mean a lot of things across various domains, but to be much more specific, computer vision. I'm going to basically just be showing this video and explaining why ROI is important to us. Now, take for instance, you have a project you're working on, a project to count the vehicles that are moving across the road, or a project to know vehicles that are moving over the speed limit. So basically, you have to calculate the velocity of the vehicles. Something that's going to be very important for you to do is to identify a specific region within the video to be able to perform those computations. So that's the process, ROI, region of interest. So how do I know the coordinates for specific regions? Now you can do that in two ways. You can either be like me during my early days when I used to guess the coordinates and then I'll draw the line and then come back again if it's not where I want it to be, I'll then guess another one, which is a very bad way of working. Or you can basically use this code that I've written down here. Now, let me just quickly explain what the code does. So first thing we need to do is we need to import OpenCV because OpenCV rocks. And then we define a function which basically acts as a callback. And we specify that we want it to act as a callback with this cv2.set mouse callback. If not, it's just going to be an ordinary function where we pass in the function name, as well as the named video that we define here. Now it's important to, when you are doing your cv.inshow, to also pass in that named window as well, which is that. So it has to be consistent across all those places. So now with the function, what we just do is basically we are checking for an event. And what's the event? The event is basically our mouse event. So whenever the mouse is moving, we want to identify the coordinate of the mouse and print that out. That's just what it does here. And then we read the video that we want to use this on, and then we set the count to be 0, which helps us to be able to. I should definitely remove this. I don't know why. It helps us to like we basically read every third frame, which isn't so important because I set the window key here to be 0, so it basically stays on the same frame. So I definitely should remove that. So basically we read the video and then we resize the frame to a specific size, and the reason why I'm resizing the frame is because the original size is really big and it covers the entire screen, so I want you to be able to see the output. And basically after we've done all of this code, in case you're not familiar with this code basically just counts breaks whenever we press the key on our keyboard, and we release and destroy our window. So let me just quickly run that in the pipe and show you how it works. So remember, we're trying to get the coordinates. Okay, now it's live now. So if you want to get the coordinates, we basically just move our mouse around, and you can see this thing by the left side of your screen. You can see the coordinates that are being printed out as I move my mouse. So that's the event. So let's say we want to identify a specific point on this highway here now. We just go to the point where we feel is good, and then we write that down, 182.158. And then you come to the other point because we want to align, and you get the coordinates for that one as well. You can then get the coordinates for this, get the coordinates for this. I mean, this thing can help you do lots of things, especially in situations where you want to do a traffic count, and traffic count for an intersection, sorry, where vehicles are coming from multiple areas. So how am I able to identify vehicles that are coming from this area and this area? This ROI is what helps you to be able to create a region in the frame that performs those computations. I'm going to be doing lots of other projects. I'll be making use of this ROI. That's why I'm making this video, so that you have this basic understanding of how to get the exact coordinates. And that's basically it. Just to show you an application of this, I have this code written here. I'm not going to be explaining this because this will take a lot more time. But basically, this code is basically to calculate vehicle speed. And you can see here I already listed out the coordinates. This is for the left side up. Sorry about the naming convention. This is for the left side down, this is for the right side up and the right side down. And then I have a couple of other things that I listed here that helps me with the calculations. I'm not going to be explaining the video, but basically the way it works, the code is running now when it comes to the receive. The way it works is whenever a vehicle passes the first line, we capture we basically start the timer. We start a timer and we identify the exact coordinates of that object and we store that somewhere. Then when the vehicle gets to the second line, we then do a calculation where we identify the distance that the time, sorry, first of all, the time that it took for it to get from point A to point B. We capture that time and store it somewhere. And then since we now have the coordinates, we now have the new coordinates for that particular object, we are able to perform something that is very simple. It's basically JSS1 physics, and that is just distance over time, and we get the velocity. Very easy. One thing that I will mention is that it's important to make use of GPUs, although I don't have access to GPU. And the reason is because because we're making use of time. So, and basically when you make use of GPUs, you can run these applications in real time. You'll see now that it's going to be lagging, even though I'm using nano version of YOLO V8, it's still going to be lagging. But if I had access to the GPU, which I don't have here now, but assuming I use the headless device, you wouldn't be seeing the output, so that's pointless. But if you had access to a GPU, it will go in real time, and so you will be getting correct calculations for the velocity. So I wonder why this is not coming up, but very soon. Okay, let me pause the video, and when it comes on, I'll play back. So hi guys, welcome back. That took some time because I don't have access to GPU once again. So this is actually the application running. You can see that when an object passes through the first line, it's the color of the line changes, and that's just basically to indicate that we've captured what we need to capture. So now you can see when it passes through, it's 5.44 meters per second. Again, I just want to emphasize that it's really important that you make use of GPUs, except you know the exact frame per second that you're going to be lagging behind, and then you can add that to, you can just basically augment that to the code. But apart from that, you need access to GPUs. If you have not GPUs per se, just one T4 16 GB should be good because we're making the nano version here. So with that, everything here would run in real time and you'll be able to get accurate results for the velocity. But again, that's not for this video. But in case you really want to know about that, then just leave a comment and then maybe I can make that as the next video. So thank you very much. That's all for now. If you found this video interesting, kindly leave a like button and leave a like. If you are interested in lots of computer vision stuff, you can subscribe to my channel, and I have a lot of cool stuff lined up. So thank you very much.